as we can. And it's 3 o'clock. We're going to get started here and hold up this connection. Greetings to Seattle. We also have Great Long Beach on here. It's great to see people on from all over the country. So please stay tuned with us, keep with us, and I'm going to be talking about PBL and STEM, something that I think is so exciting here. And this was my little, anytime you see something like this on the menu, what I'm really encouraging you to do is to go ahead and share in that chat window. And I'm going to give you some little prompts to share in the chat window, because this isn't just me, it's all of us together learning from each other. Welcome to BIE.org, the Buck Institute. Some great information we're going to be bringing you today. I'm sitting here in Fort Wayne, Indiana, home of rain right now. Rain, freezing rain. Iowa, like I said, you didn't quite send us the snow, but it's great to be here. It looks like Minnesota, you're actually in a warm spell, up to 30 degrees, Christy. That's great to see. This is myself. I am actually in my backyard there here in Indiana. A little different season, but some of the things that I do along with BIE, I am actually work for a school system and in charge of the one-to-one with the schools here in Fort Wayne, Indiana. Do some work for Discovery and some other things that you can see as you go along that list there. It's an honor and it's a privilege to be here today and to present for BIE. I'm just really, really happy about that. And anything that I give you today, I promise you, you're going to find it, and I will show you later. Don't worry about taking notes. I'd rather see you in that chat window having a lot of fun. And everything that I give you can be found at 21stcenturyedtech.wordpress.com. So if there's anything you copy down today, and I'm going to show that again, get that, because all the links, I'm going to go over about 20 links today of some great resources. But the other thing I'm going to share with you is about 25 more things that I have buried in a blog that you are free to take a look at and be part of. I actually ran an integrated solutions block, and what it was is we combined all the subjects and we integrated with technology, PBL, STEM, 21st century skills. We had all the kids be part of that. Currently, I direct a one-to-one initiative with 1,800 middle school students and 2,300 high school students. So I am used to working a lot with some of that networking. Your experience with PBL, please feel free to share in the chat. You've told us where you are from. Possibly jump into that chat and tell us a little bit of what you do. What are your responsibilities of where you work? What I want to do as you do that is I'm going to give you a little bit of a PBL Quick Start, the 8 essential elements of PBL. But with those 8 essential elements, what I want to bring you is how they connect with STEM. So keep that in mind as we go through this. Now, first of all, our first thing is significant content. And if you're into PBL, you know you have to drive down and you have to drive home that content. And in STEM, we do the same thing. We have the science, the technology, the engineering, and the math. That is our significant content. But along with this, we have 21st century skills. And let's not just call them 21st century skills. Let's talk about critical thinking, collaboration, communication. And I'm even going to throw in creativity as an important one there too. So it's something to keep in mind. The next thing we have to think about is inquiry. And that is so important. How do we get kids to ask great questions? And STEM is a great way to do it. The driving question, remember, that's even better than that actual engaging type questions or whatever. What we do is we use it to engage kids, and we connect them to relevance with a driving question. And through that driving question, we get into the needs to know, because STEM allows for exploration that uncovers all that content. Voice and choice, and we can let our kids go out there and really, really work with some of these types of things as far as things they are interested in. And voice and choice is a part of PBL. It's definitely a part of STEM. Revision and reflection. I think this is a huge piece of PBL, but it's also a huge piece of STEM, because a lot of times what we've done in our schooling is we've gotten so much into the content that we don't go into the formative learning of allowing our kids to actually go through and tinker. And tinkering is one of the biggest things that I think that we learn from. I go back to the age of when I was growing up, Tinker Toys. Some of you may remember that too. And the last thing, the actual public audience, students demonstrating what they've learned, the problems they've solved, and all types of things. So this all adds up into those 8 essential elements. Now, any good PBL project starts with an entry event. And my entry event happens to have 2 objects or people here, Dewey and Sputnik. And the amazing thing about Dewey and Sputnik is they didn't even exist at the same time. But to me, they brought a transformation in education. Of course, John Dewey getting us to think into this new type of learning, which eventually evolved, I believe, into PBL, but also Sputnik, because Sputnik was our wake-up call to STEM education. I see somebody loves the Tinker Toys. That's great. If you want to really get creative, think about the smell of crayons too. That's always a lot of fun. So between the two, Dewey and Sputnik, we had these connections. We had this transformation. And I have a quote here because it's something that I really think about a lot when we get into STEM education. And take a look at this quote. Method means that the arrangement of subject matter which makes it most effective in use. Whoa, think about that. Arrangement of subject matter which makes it most effective in use. Never is method something outside of that material. Think about that for just a second. And as you do, share something in the chat like, wow, this was really like a big moment for me, or I think I'm confused. Arrangement of subject matter, what are we talking about here? And go ahead and feel free to have anything you want to talk about PBL and STEM in that chat room right now. As I get into our today's Craig, I'm glad you love the smell of crayons there. As I get into the driving question of how can we as educators integrate the 8 elements of PBL to affect and engage STEM learning opportunities. And that's what we're going to talk about today. The first part of this, I'm going to go over some philosophy here, and then that last half, I am going to really open up that fire hose on some pretty cool resources you might want to take a look at. So our needs to know, which is really important. You can see the needs to know what we have here today. And our first one is, what is STEM? Well, definition, let's talk about before STEM. And this is like when I went to school, we had science class, and science was taught separately outside of everything. And we had technology, and it was kind of locked to its own time period. And we had engineering. We called it drafting, okay? And I remember, because I think one semester I made a spoon, and then I think the next semester I made a spoon again. One was in metal and one was in wood. It's really changed today, gotten a lot more elaborate. But engineering, and it was taught separately, and math, it was taught separately. You see, all of these subjects were really each in their own little world, and they were all taught separately. So, separate boxes opened by teachers for their students at different times. And you've all experienced this. I know when I would teach math or I would teach science, I would say, well, remember this from math class your teacher talked about? No, a lot of times they didn't connect. It's all at different times. And what I want you to think about for a second is, where are most schools today? Where is the school you're working at right now? Have you combined the STEM disciplines, or is this still separate? And I'm not saying that being separate's bad. It's just some things we have to think about if we're doing that method. Okay, let's go back to why we want to combine this. And I'm sure a lot of you are familiar with the TIMS and the PISA testing. And if you're not, Trends in International Mathematics and Science Study, TIMS, what it does is it tests the kids' content knowledge. And you want to know something? Here in the United States, we're not doing bad. Like we were, I think, 8th in 2007. That's not bad, because you got to remember, here in the United States, we are educating every kid. We're testing every kid. And as you look at TIMS through the breakdown of math and science, you can start to see that we're always pretty close to that top 10. In 2003, we were a little bit lower there. And this is on content. Believe it or not, we're doing a pretty good job of delivering content, and I think it's probably because of the way we're set up and the way we test. Now, let's take a look at the PISA test, the Program for International Student Assessment. And as we look at this, we start seeing that this is more overarching ideas of curricular-based areas. So we're asking the kids to apply what they know, okay? And the stats basically, and I'll share with you, are coming from PISA themselves, and you can see, in fact, I've got bookmarked there the 2006 results, and you can see where that is under the surveys of the government there. But you can start to see that we're 25th out of 30. And as we take a closer look and drill down into PISA, you can start to see that we are not doing it. And the major thing I like to let people know is we're not doing quite as good a job of getting kids to apply the content as we are at getting them to know the content. And I think to really know it, we also have to be able to apply it. So why is all this? Well, I think we're keeping all of this still in separate boxes, okay? Even though the concepts and standards are connected, we keep them in it. And you see, STEM and PBL, as we look at it, they really do connect with each other. And that is so important because STEM is the content. Remember, as we talked about those 8 essentials, science, technology, engineering, and math. It's the content. And I see PBL as the process, and it's the glue that can really bring this all together using those 8 essential elements. And so the power of PBL takes those separate boxes and it connects them into one new box, one new authentic product. Remember Dewey? Method means that the arrangements of subject matter which makes it most effective in use. And so think about that as we start talking about STEM. So how are PBL and STEM related? Well, first of all, there's a natural partnership here, okay? And I want to welcome you to a new box, PBL and STEM. And it's more than a box. It is a process, okay? And when you open this box, PBL allows us to connect all of the STEM disciplines together. PBL is the real world. It brings the authenticity to STEM. It makes it real, which is what is so important. You see, it also promotes inquiry. It's the natural process that's found in STEM disciplines, and it can drive STEM. And it can really help us with that driving question and what we want to uncover. It also provides a reality, and it allows us to have that here and now, and it lets us go out into the world and really experiment and problem solve. And it also provides a foundation, because in this foundation we have STEM on one side, we have, which is the content, and we also have 21st century skills on the other side. And between the two, we ride our STEM curriculum. Both are important. Don't go all content, but on the other hand, I've seen some people go all 21st century skills, and I walk in the classroom and I say, hold on, where's the content? And so you got to be careful of both. I see that a lot of times in technology too. So they really are a perfect match, really are. So keep that in mind. Now, as we get into STEM and PBL, one of the things we have to think about is the why, what, and that's what we a lot of times work with. And that's, I call that the math, science end. We're always talking about the why and what, but are we also working with the engineering side? And you're going to see this in the new science standards. Engineering is going to really be brought out. And what you're going to see is the actual application and how. And as we talk about application and how, we actually get into this idea of how much are you in your schools doing this apply and how, okay? And that's where that engineering, that's where that technology is really going to be brought out. And I actually say to science people and math people, as you do this, think about the apply and the how, and how you're bringing these things out, because that really is part of the new, especially the new science curriculum, and the Math Common Core. Okay, what are ideas to promote PBL and STEM? Well, first of all, ideas to reflect on include take it slow. Do one project. Unless if you are a PBL-based school, just start with one project. Now, notice that I said one outside standard. What I'm suggesting a science and math person to do is to go out there and pull a standard from another curriculum that connects. Even if you're just one teacher, at least you're taking that one small step into the world of PBL and STEM. Also look for common core, common plan, common ideas, common time. All of this is so important. And find something cool to replicate. And whether that means a web exploration, jump into a professional learning community, any type of STEM program, any of those types of things. Try to make that happen. And here's another thing. And go ahead and please throw in the chat window some of your successful after-school programs, if any of you are into some after-school programs, because kids love to come to those things. But you see, why don't we take some of these things that are after school and bring it into our actual curriculum, which I think could be very, very powerful. Make the time. That's important. Collaborate, negotiate, align, experiment. Do all of these types of things, because that will help you with all of this. Create plans that integrate, okay? And as you do that, that will help you facilitate that journey, okay? It really will, and as you think of those types of things. Last, involve your entire education community, okay? Your parents, your schools, your businesses, your government, your higher ed, your industry. Involve all of those types of things, because it's all so, so, so important. Engage yourself and others with passion, with enthusiasm, with excitement, with diligence, with commitment, okay? And try to make all of that happen. I'm just going to type something into that chat window. I haven't seen anything put in here for a second. I want to make sure that I'm still connecting with you guys. So if you can give me a little chat back, at least I know then that I'm still connecting, because I don't have a good way of finding out any other way right now. Like I said, I'm kind of working on this. Great. Thank you, Andrea, for putting something in there. The minute I see that chat window die down, I start going, hold on, am I still getting out there? Because it's hard for me to monitor that. So thanks a lot, everybody. Okay, I promised you some web resources. Nashville, great to see you there. I was just down in Nashville, Sandra, doing some work with the Nashville Public Schools. So really great. Great to see some people processing, all that type of stuff. Thanks for hanging on there in that chat window. Now, I'm going to actually bring in some collection of web resources for you that promote STEM. And I'm going to start off with some PBL type ideas. And as you get into the web, what you want to do is you have to start thinking about web resources that provide a footprint for an entire project. And I'm going to share those with you first. Or there could be some web resources out there that you already have a project and all you need is a scaffolding piece. Okay, so keep that in mind. It could go either way. And these scaffolding pieces could be a product idea. They could be a needed lesson. They could be a foundation for your PBL and STEM. And so if you know of a great PBL or STEM project that you're doing, go ahead and share that in the chat. And as you do that, I'm going to take a closer look at a couple sites here. And one of the sites, of course, we're going to look at BIE, because if you go to BIE and you do a project search, and this has been updated since I did this screenshot, you will find hundreds and hundreds and hundreds of projects. If you know of some place where there's some great PBL projects, put it in that chat room, because I want to get a recording of those and add those to my sites. But anyways, as you go into BIE, I clicked on science here, and after clicking on science, I thought, hey, I'm going to take a look at physics in science. And from physics and science, I went through and I found these things. Now, here's what's cool. I found these different projects, and take a look here. Math, science, math, science, math, science. I'm looking at STEM related things. I really like that last one because it brought the arts in, and I'm a big advocate of STEAM education. And when you put the A in STEM, you get STEAM. The arts are so important because it is the arts that really drive innovation and creativity. So keep that in mind. Some of you arts people out there, get those kids innovative, get them tinkering, get them playing, get them smelling the crayons. Here's a math look, and I took a look at math, and I saw a math and science thing. Now take a look at this next one. Here's just math, but I went and read what it was. Architectural planning. Wow, isn't that engineering? Isn't that technology? So again, I've got a STEM-related type idea. So go ahead and use BIE. There's some great resources there, but I'm not going to stop with BIE. West Virginia Department of Education Global 21 has some great things. Thank you, Craig. Has some great things out there for you. And as you get into their items, you will notice that you can get into their website and you can look like science, physical science, and you can get into their different PBL projects. Now, the reason I pulled up West Virginia here is I wanted to show you what their outline looks like here. Take a look here. Here's a title, who created it, the project idea, the entry event. Remember, we talked about entry events are important. The power standards, the content standards, all these types of things. Here is 21st century skills, performance objectives, the application, the how. That's what we've been talking about with performance objectives. The driving question. Assessment plans, and the assessment not only covers the content, but it does cover the 21st century skills. So I really suggest you to take a look at what the state of West Virginia has developed here and some really cool stuff. My third site, you may not know this one. This is called Learning Reviews, and it connects kids to learning on the web, but I like their project-based learning area. And as you go into here, they've got it for language arts and science and math and social studies, but I thought I would just concentrate on science. So here in science, here are all of the earth science things I found. Now take a look. You're really looking at over 100 projects here because every one of these, what it does is it digs through about 30 different websites and pulls PBL information from those websites, such as the JASON project, such as ePal, such as My Science Box. And notice that every one of those, like the geology box there with My Science Box, has 19 projects in it. And as you dive into it, you'll see some more in space sciences, engineering, chemistry, of course, the different math areas that you will be able to find. Here's what some of the projects look like. Again, very engaging for kids. A lot of neat things you can do based on innovation, problem solving, that you can incorporate into project-based learning. So Learning Reviews is another one of those that I really, really, really suggest for you. That's the end of the tour of those sites, but I want to take you on some more. We're going to surf the web here a little bit because I've got some free STEM PBL ideas that can scaffold into your projects. And one of the things I love to do is, please, again, share in the chat window. You know of a great just STEM site? I'd love to learn from you. Throw that website in the chat window because, again, let's keep that chat window going. It's great to see you guys being your own PLN. Now, as we get into this, the Siemens Science Challenge is one of the greatest actual challenges out there that you can use and incorporate into a PBL unit. And they've got one for elementary, for middle, for high school. And one of the things I tell people, you don't have to do the competition. In fact, the competitions are over in a lot of these, but you can use the resources. They have lesson plans, they have videos, they have virtual labs, and you can use this all to scaffold different things. Take a look at some of the different things within their middle school virtual labs here at the Siemens Science Challenge. Some great stuff, but maybe eventually you want to be part of the competition. That's a great project, and you talk about authentic. How about the Kids Science Challenge? Imagine your kids learning about playing sports on Mars. Or how about bio-inspired design? Wow, you talk about STEM. We study insects to get a better idea of machines and robotics. Well, that's what scientists are doing. So it's something that you can really get to know. Hey, I love iEarn.org. Thanks for sharing that. Craig, I see that you've got Game Mechanic, a wonderful site for learning how to build some games and stuff like that. And like I said, iEarn has got some great things for some of you interested in actually some things across the world and applying science knowledge in a global community. Well, anyways, Kids Science Challenge, as I've got here are just a couple of the little activities. They're loaded with videos. Now, when you're in Kids Science Challenge, click on Pulse of the Planet. You will love Pulse of the Planet for scaffolding multimedia type activities for you, because in this you get 2-minute podcasts. They can be run on your iPads, they can be run on iPod touches, your smartphones, or they can run on computers, and they're 2-minute little podcasts from experts, and they're filled with lesson plans for you to be able to use. I'm just showing you a couple programs that I found just when I was looking at oil spills, because I happened to do this search during the BP mess down there in the South, which we're learning a little bit more of now as they go through. And the Young Scientist Challenge is another great one. And this is through 3M. They've got some wonderful things. Thank you. I see some more things coming in, Patty. That Texas Girls Collaboration Project, I've got to take a look at. That looks like that could be interesting. But 3M has some wonderful things for you. Here's more things on the Young Scientist Challenge. And again, what I'm doing is I'm showing you how you can get in and scaffold with different types of ideas. And you can see the different types of activities and extras that are part of that Young Scientist Challenge. I love this Jason project. It used to be free. There's a small cost now. But one of the things I keep the Jason project in this presentation for is because so many people buy digital textbooks. And I say to people, do you want a digital textbook or a digital curriculum? And there is a difference. We don't want just a bunch of PDF files. That's the same thing the kids have been getting. And I think this is what the Jason Project does good, is they actually allow kids to go on adventures, and they have different types of games and curriculums. And you can see the different units they have, a geology unit, an energy unit, all just fascinating for all of these. And I noticed that Annette's asking about the link on Kid Science Challenge. That will be in the blog that I also give you. I'll have a live link for you at the end of all of this that you'll be able to get into. So don't worry about that, because some of those links are long, but thanks for asking that. We've got the ecology unit, the weather unit. One of my favorites is this coaster creator, because rather than have kids just build a coaster and see if it works, it actually applies mathematical equations that run at the same time, so the kids can see the actual math that's done in a coaster. Some really, really, really cool things. Well, as we keep on going, here's Storm Tracker, another thing that you might be interested in, and some mini labs. Discovery Ed, Siemens. I don't know if anybody has found this one, but some really good things. And thank you, Patty, for putting that in the chat window there. But Discovery Ed and Siemens, I would say their big strength is if you want some great webinars. In fact, I'm trying to look at the date. I think it was yesterday. They actually had a webinar where they had the kids take a look at a new telescope with this huge mirror, and they provided that webinar during the school day, and then they did a continuation of it at night so kids could go home and look at it with their parents. What a great way of engaging parents and bringing parents in. So I really push the Siemens STEM Academy, especially because of the webinars they have, and they are both for kids and also for professional development of teachers. They actually have a pretty good blog too. I actually write their blog for them. So on STEM education, you might want to take a look at that blog sometime. But anyways, here you can see some of the different webinars that they have had. Some really great things from experts out there in the field, whether they be talent from the Discovery Channel itself or famous scientists, and especially being centered right out there in Washington, D.C., they have some good access. And they also have some teacher resources on their site, and you can see some of the ones that I have here that are really, really, really powerful. I also encourage you, I think the Institute sign up is done, but every year they have what's called the Siemens STEM Institute, and they fly 50 teachers out every year, free of cost, stay in Washington, D.C., and go around Washington discovering all of the STEM-fastic stuff that is there in Washington, D.C. Really cool experience. If you have never heard of EGFI, what a wonderful resource. I would say this may be one of the best STEM resources on the web. I love it. You can start to see some of the content. Look at that driving question. What will engineers think of next? And they get into all the different news of what engineering is doing. And they provide you with all the different types of careers and occupations you can find in engineering. And how about this? They have a teacher area. And in this teacher area, you will find lesson plans, class activities, K-12 outreach programs, all kinds of things. So a really, really, really great program as far as this. How about web resources? And now, if there's one thing you do, go to EGFI and sign up for their K-12 education newsletter. They will send you a newsletter, a beautiful PDF file once a month, filled with the latest news in STEM education. So if there's one thing you walk away from on this webinar, I hope you walk away signing up for their education newsletter. It is just awesome. Some great things in it. Here you can start to see some of the different lessons. Look at that. Build an earthquake-proof structure. And it's just using soda straws and stuff like that. So they actually get into some things that you can bring into your project-based learning as scaffolding type activities to help kids understand things. If you've never done National Engineers Week, it's a great activity, and it uses the game Sim City. Talk about instant engagement. And then kids use this game to build their own city while they address a futuristic problem. It's also a competition, but you don't have to, again, be part of the competition because they actually have learning blocks that are aligned to a lot of the national science standards, and you can go in and do portions of it. But just a great, great way to get to know some things as far as engineering. Teach engineering, some great things, all different types of subject areas, lessons, activities. Going into Teach Engineering will show you some really great things. Another one I like is Discover Engineering. I loved their skateboard legend and some of the things they have and their video activities. Design Squad Nation from PBS is another good one. And the thing I like about Design Squad Nation is they get the kids actively involved through videos and games and contests. But here's what I really like. They encourage the kids then to blog it. Now we're talking Common Core standards. We're actually talking about bringing the literacy into the science curriculum. And so it's another one at Design Squad. Take a look at that one. Here's some of the activities they have at Design Squad. You might really like doing some of those animations that you will find. Google Science Fair, why not do it online? And why not have the kids actually collaborate with other kids across the country, across the nation, across the world? Some really great possibilities with Google Science Fair. The Khan Academy, I'm not going to talk about that much because we're aware of it. Remember that it is a scaffolding type activity. It can really help the kids with significant content. But remember, it's just one avenue. And I could talk about flipping. A lot of times people talk about flipping the classroom. I don't really, I think more of not just flipping instruction. I like to talk about flipping learning, but that's a whole other webinar. WGBH in Boston from Teachers Domain has all of the PBS programming. Now they're shifting all their stuff over to actually a site that's going to be called pbs.org. And you can actually bring out lesson plans, and they have segmented videos, like in 4 or 5 minute chunks from their different programs that you can bring into lesson plans that will help you as far as some of the things you do. One of my favorites right here is Science Net Links. I actually wrote up a blog on this one. I was so impressed, and let me show you why I was impressed with them. Here's the front page. They have all their different tools you can use and all the different things in science. But I thought I'm going to take a look at one of their projects. And so I went into this one that I just thought I'd pull out, and it was actually, see, I love anything where kids have to read too, because I think literacy has to be pushed also. And as you look at this, here's a science project that the kids read a book as they're doing the project. And take a look, there's context. They talk about motivation. So we're getting into this whole project, the development of the project, and they give you all of the information that you can use. Some really cool things here. How to assess, different extensions you can use as you do it. And take a look here. They even give you different related resources within Science Next links that you can do at different seminars, different things on climate change. So all of these things, this is, I think, one of the underused sites out there that not enough people know about that you definitely want to take a look at. So here's where I'm showing you how you can actually search for lessons. This is how I found this one on the wild trees. Excellent resource. Any Wolfram Alpha users out there? If you've used Wolfram Alpha, let me know in the room, because I'm going to show you. This is, I like to not just show resources, I like to show you something kind of fun and new that you may not be aware of. But so we're going to dive in and take a really quick look at Wolfram Alpha. It's a search engine, but I think STEM educators should know about Wolfram Alpha. And the reason I say that is because it's a data search engine, not an informational search engine. Think of Google as informational. Well, think of Wolfram Alpha as data. But let's take a look here, and if you've ever used it, you can share how you've used it. If you haven't, stay tuned. I think you're going to love this. Here's what it looks like. Now, they've changed their interface since I did this. It's now more of a green look. But I put in an equation, and once I put in the equation, it gives me the answer, as you can see there. Well, math teachers go, oh my God, this is terrible. Kids are putting in equations and getting answers. Well, isn't that what the back of the math book has always done? Because what we want to do with kids is we want them, again, to apply it and tell us the how. Well, it actually shows you a little bit of the how as you dive deeper into the equation. And I can actually tell it to plot something. Now take a look here. I actually get a plot of what I put in, but it goes farther than that. Remember, it's informational. How about the area of a circle with a diameter of 10 inches? It gives me the answer. It even graphs it for me. And I can actually have kids explain this and talk about, why does that graph make sense with what we're doing? Oh, more things on that circle. Well, I'm going to get real life here. I'm going to ask Wolfram Alpha, what's the nutrition of a Big Mac? It knows it. Take a look at that. It's giving me every information I want. Think about how you could use this in data collection and having kids go in and try to find information, graph it, talk about it, argue about it. All of this just on the Big Mac. I could have said compare Big Mac to a Whopper, and I would have gotten that. How about the number of volcanoes in the United States? I'll let that explode for you there on the screen for just a second. And we find all of the volcanoes, and when we click on one of them, we get information about that. We can even click again, and we're going to get a satellite image of it, and we can go into that satellite image. We can get graphs on it. We can get maps on it. All of this from Wolfram Alpha. Maybe you're studying the elements. Here's krypton. Take a look. Krypton in the periodic table, or everything you always wanted to know about krypton. This is all part of the search engine. And so I hope some of you are already out there. You're listening to me, but you maybe opened up another window and you say, hey, I want to go play with this for a second. How about compare the birth rates of the United States and Canada? So I type that into my search, and it gives me what that comparison is. Or elementary kids might want to know, they're studying the puma, the lion, and the red fox. And so I put that in. It brings up all three and starts comparing them for me, listing them on how they are listed and what kingdoms they're in, classes, orders. It even tells me, I didn't know this, the lion lives 30 years, mountain lion 23.8 years. I wonder why the difference. You know, I mean, there could be some interesting things here, and I even get a picture of them, of course, too. And, of course, where they are in their kingdoms. So whenever you go into Wolfram Alpha, you can use it as a search engine, or you can click examples, and here are all the different types of examples of how you can use it in the classroom. So you may want to go through that, take a look at these things, and click on them and learn more about how to use Wolfram Alpha. And one of the things I've got here, when I clicked on one of the examples, I clicked on planets, and here it tells me how to do some some testing. And yes, it is free. Okay. Now I do think they're into the world of selling some of the apps, and there are portions, but the actual search engine is totally free. Sometime what you might want to do, go into Wolfram Alpha. I don't have a screenshot of this, but type in flights over and then put in your city, and you'll actually get a real-time picture of the planes that are over you right then, where they are, where they're going. It's really, really cool. So you might want to take a look at this. Wolfram for educators, you can go into that site and it'll actually show you some different ways that you can use it in education. It'll give you some lessons you might want to take a look at, and then using actual Wolfram Alpha in those lessons. And here's a video gallery, and it'll show you different videos of kids using it and how you can use it in the classroom. So just some things you might want to take a look at. I could keep on going on Wolfram Alpha forever. There's actually a player that you can use with it. So I bring this up because I think it's something. I don't want to just show you resources. I want you to be able to go out and play with something new possibly too. MIT has got some great things. MIT Blossoms actually has video lessons that you can use in your classroom, and you integrate with experts they have in the field along with what you say, and then they give you the experiments to do. MIT also has a great newsletter called MIT STEM Pals, something you might want to take a look at. Here's some of the lessons at MIT Blossoms, and you can see some really, really cool things. Now, my favorite's coming up here. MIT K-12 video. Okay? MIT has actually asked teachers to jump in and join, and you actually sign up for an account, and then you create an assignment. And the assignment you create is actually taking like some type of concept in science or math, and what they want you to do is give that to them and ask their MIT students how to make a video. And the MIT students then make a video that kids can understand, applying it to real life. And this is for the students at MIT right here. And so together, let me show you, here's some of the videos that have been made. Indoor flying robots, pixel engineering, forces on an airplane. I love this one. They talk about the scale of the universe, and they use the city of Boston to show you what this scale is like. These are just awesome videos done by MIT grad students for K-12 kids. Something you definitely want to check out. Free software out there? Well, let me show you some really quickly. If you know of some STEM software, go ahead. Or if you're using some of this, let me know in that chat window how you might be using it. SketchUp. Any SketchUp users out there? If you use it, it's a lot of fun. The kids will learn it faster than what you know, and there's a lot of great tutorials on how to use it. It can be used for measurement, engineering, geometry, innovation, and design. I had the kids make avatars. These are kids from my classroom, and I told them how avatars are really a part of CAD. It's part of engineering. And so they made their own avatars with SketchUp. SketchUp is free. How about transportation? These are all, I just wanted to share with you what some of my kids did in the classroom. How about innovation? Okay, and you could really get some cool things doing. You talk about making it steamy. Here's one where we brought in the actual Common Core literacy standards because they created a community of Arctic treetops, and then they had to explain it in paragraphs. Any West Point Bridge users out there? West Point Bridge is probably one of the neatest free programs. The kids build bridges on the computer and then test them. And they learn all about tension, compression, all of that type of thing. Here's a picture of that truck ready to go over the bridge, and you can see the orange is representing compression, the blue tension. And then you can get mathematical, and they can actually bring out ratios on them on a spreadsheet. Really cool things. I've done this. I've seen this done with kids in upper elementary. I used to do it extensively with a lot of 7th graders, and it's free. They can download it at home. Another one of my favorites, and I wish I could show you videos, but we kind of have trouble with that bandwidth on that. But Scratch is just awesome. Scratch was developed at MIT, and it's a computer-based building program, and it allows kids to make interactive stories, games, music, art. And it provokes imagination. Again, you talk about turning up the steam, gets kids into programming, mathematical thinking. SketchUp could be used anywhere, I would say from about 3rd grade to all the way up into high school, okay? And if you want to learn more about Scratch, I have a webinar, and this is hosted at the Siemens STEM Academy. It's called Learn, Create, Innovate with Scratch. Of course, it's already done. I did it with Steve Denbo and Hall Davidson at Discovery Education. But you can still go and find that webinar. It takes you about 50 minutes to watch it, okay? And what I do is I show you how to get started with kids, how to get going, what lessons the kids can actually find online to teach themselves, and I'll guarantee you within 2 days your kids will be far ahead of you. But that's what it's all about. I don't know if you're into music. I want to turn the steam on again here, but Dr. Lodge McCammon has a site called iamlodge.com, Beans, and he puts science and math to music. And here's some of and he actually suggests teachers then to act these out, have kids actually make a one-stop video on these types of things and actually act them out. Very cool things. Here's just some of the lyrics on one of the songs he has, and you can play them and all that type of thing. Very cool stuff. And brain research, of course, has shown that this can be really powerful in retention. Google Earth and Maps. I don't know if we have any Google Maps users out here. We're running low on time, but I'll try to run through this slide deck really quick for you here. And when you get into Google Earth and Maps, there's a lot of great resources that are free for educators that will show you how to use Google Earth in the classroom. And here is something like you can do global historical temperatures, real-time earthquakes. These are all lessons that are available for you from Google. If you know of an activity, go ahead and do that. Let me show you one really quick thing before we run out of time here. And I'm going to take you into Google Earth because you've all probably done a little Google Earth tour. And you know that when you do this Google Earth tour, you can click on something there in Google Earth and it'll take you somewhere. Well, how do you find these places? I do an actual workshop where I actually teach people how to search using both Wolfram Alpha and how to use Google itself as a search engine. And I call it my advanced search workshop. But I'm just going to show you one little piece of that workshop, and that is how to find a Google Earth file online, okay? And they're called KMZ or KML files. Well, what you do is you go to Google and you see that little advanced search button after you do it. You have to do a search first, then you'll see an advanced search button, okay? You click on that and it gives you this screen. Well, what happens now is you go to file type and you tell it the file type you want. I'm going to click on over here and I'll show you what I mean. I just put in ancient Rome as what I'm searching for, and I said, look for KMZ files, or it could have been KML, either one. So when it looks for that, I suddenly find all of these sites here that you can actually learn about and have trips on Google Earth. When you click on one of these, it downloads it to your computer and saves it as a file. It'll ask you where to save it, and you can save it on your desktop. And here it is. I've saved it on my desktop, and now I'm doing an architectural study of ancient Rome. And I can have the kids go to each one of these things, and it's all been saved for them. They can save the file on their desktop by just doing a simple little advanced search. Now, you want to use this file again? You don't have to search for it again. Just click on Rome, the file you downloaded, and say Save Place As. You tell it where to save it on your computer. You give it a name. It saves it as a KMZ file, and it's there for you to open up later when you go to Google Earth, and you don't have to go online every time to do that. It's very, very cool. So just one little thing I thought I would show you. I like to show people little tips and tricks. Movies, Movie Maker or iMovie, use those. Teachers are flipping the classroom. They're flipping instruction. I still say flip the learning, but why not have the kids make the movie or the iMovie and have them explain the concept? Two things happen. Number one, they learn it better because they've had a chance to explain the concept. They've thought it through. They've written the script for it, and they might be able to explain it better to each other. So some really, really cool things as far as that. Hey, we're ready to wrap up. Method means that the arrangement of subject matter which makes it most effective in use. never as methods, something outside of the material. Remember our driving question? It was, how can we as educators integrate the 8 elements of PBL to affect and engage STEM learning opportunities? Well, that's what you need to do now. It's up to you. And you see, the bottom line really ends up being STEM is productive. It's relevant. It's practical. It has those connections that promote the understanding that you want, and these connections put real world experience is in the hands of your students. And isn't that what PBL is all about? You see, PBL and the 8 essentials, all of them, driving questions, significant content, revision, reflection, public audience, voice and choice, in-depth inquiry, need to know, 21st century skills, they integrate into the STEM curriculum. They're really made for each other. So it's true. STEM and PBL, they really, really, really are a perfect match. And the time is now for you to get your next move going, and PBL and STEM, put it in one box. Now, I just went to my website here. This is my blog. I know that some of you go to it because I've seen your names in there. And in fact, you might really enjoy this article I just wrote. It's called 10 Ways to Ensure Significant Content is Part of Project-Based Learning. I think you're really going to like it. I'm doing a whole series on project-based learning right now, and I really, really am stressing, and there's a good handout for teachers to go through, a reflection sheet on getting into significant content. But now, when you go to the website, if you look over to the extreme right, you'll see these resources from Michael Gorman, myself. Well, if you go all the way down to the bottom there, there's PBL Meets STEM, delicious main course of resources and ideas, okay? And you can see my website address, 21stcenturyedtech.wordpress.com. That's the address. Now, when you go there and you click on that, here is the article, PBL Meets STEM. And of course, I've cut off, it's about 4 or 5 page article. And I'll have all of the resources for you, everything I talked about, plus more, so much more. So I really encourage you to get in there. And as you do it, go ahead and sign up for the web. I'd love to have you as one of the people that are constantly reading some of the things I'm putting out and contributing to what I put out. I also encourage you to see some of these STEM sites. And also be aware that this June, some of you might be interested in PBL World. It is an awesome conference that's held right out in Napa Valley that will actually be going through some different PBL 101s, some PBL coaching. There is even some amazing things on different things. I do one on just using the web and technology with project-based learning, and I'll be doing a session out there at PBL World on that. So I invite you, hit my website, get over to BIE, maybe take a look and take a group out to PBL World this June. There's not a better place to be in June than Napa, California. Any questions out there? If there's anything, I'll watch that chat window. You've been just an excellent group of people. I have really, really, really enjoyed. I see that Alfred just put out that they will be archiving the webinar. So feel free to come back to that webinar anytime you want. All of the links, everything that you might want is provided for you via this. You can hot link it from my blog. You can rewatch it from the actual webinar. I really, really, really thank all of you for being here today. Feel free to email me anytime. And I'm Mike at BIE.org. Again, Mike at BIE.org. And I really enjoyed today. It was really great. Thank you for all the kind words I'm seeing there in the chat window. This was just as enjoyable for me as I hope you got some good information on it. I'm coming back, I believe it's sometime towards the end of April, and I'm going to do one exclusively where I'm going to bring a bunch more websites, and we're going to talk a little bit about middle school and getting into some of the STEM type ideas for the middle schools and and things like that. Thank you so much, Michael. Great out there in Pasadena. I'm sure you're enjoying some good weather. Again, that website address is 21st Century, and let me put that on the screen. In fact, I will put that. You will see it where it says blog at 21centuryedtech.wordpress.com. Please visit me. Also, I'm on Twitter at MJ Gormans, and you'll see that at the bottom of that red under my email address, Twitter, MJ Gormans. Feel free to join me on that. I love talking to people on Twitter. I love any email and talking with you on that. And also hit that blog, 21centuryedtech.wordpress.com. And also get over to BIE.org. Some great resources for you there. Excellent handouts, excellent videos. And also that link to what I think could just be awesome for you is a visit out to PBL World in Napa in June, and to really have a chance to meet up with a lot of our national faculty and some great keynote speakers that are going to be coming your way. With that, I think Al, that's about all we've got for today. I really appreciate everybody, and I hope that you all have a great. I guess we're getting to that point where those school years are starting to wrap up here in about 10, 12 weeks. So I wish you the very best on all of that. Keep working. Have a STEM-tastic week. Keep plugging away on the PBL, the STEM, all those types of things. And we will see you both here at BIE and elsewhere on the internet. Thanks for joining us.